Hello everyone, I'm going to discuss the direction of heat flow and will explain how we can use the direction of heat flow to solve a problem. Heat is an energy which is transferred between two objects, and heat will be lost by one object, and that amount of heat lost will be equal to the heat gained by another object. So, one object is losing the heat energy and the other object is receiving that heat energy. Okay, so I would, if I said it is Q, one object is losing the heat and the other object is gaining the heat. If a one object is losing the heat, what would happen to its temperature? Yes, the temperature will decrease in the object which loses heat energy, and the temperature of the other object which gained the heat will be increased. Okay, the an object gains heat energy, its temperature will go up, and if an object loses the heat energy, its temperature will go down. So the Q, that is the amount of heat change during a thermal process, and it indicates the direction of the heat flow, the sign of the Q. As an example, if an object is gained, if an object gains the heat, then the sign of the Q will be positive. If an object loses the energy, then the Q will get the sign negative. Always, if uh, only we are talking about two objects, then the Q will be equal the magnitude or the numerical property of the Q will be equal, but the sign will be opposite. One Q will get the positive sign, the other Q will get the negative sign. As an example, if I just talk about an or two object, one is losing the energy, so its temperature is decreasing. One is gaining the energy, its temperature is going up. But what would happen? I would say this is the object one, and this is the so its temperature is goes down, and then it comes to an equilibrium point. After that point, we will not see any temperature change. It is a constant. And if I look at the temperature change of the object 2, it increases from the initial temperature, and it's come to another again to an equilibrium, and we do not see a change after some amount of time. So the both objects will come to an equilibrium temperature which is equal for these both objects. That is the equilibrium temperature. So the final temperature for the both objects will be the same value. As an example, a piece of warm iron is placed into a beaker of cool water. Iron loses 10.0 joules of heat, and water gains that exact amount of the energy, 10.0 joules of the heat. So iron is the hot object which loses the energy, and water is the cold the compound and it gains that amount of energy. So we call iron is losing the heat energy, therefore it should have the negative sign. The water, the if we refer to the amount of energy, heat energy change for the water, water has absorbed the energy, so or gained the energy, so that Q should have the positive sign. Okay, let's see how we can do this problem. A ball bearing at 260.0 degrees of Celsius is dropped into a cup containing 250 grams of water. The water warms from 25.0 to 37.3 degrees of Celsius. What is the heat capacity of the ball bearing in joules per degrees of Celsius? Okay, we are given the heat capacity of we are looking for the heat capacity of the ball, and we are given the heat capacity of the water. And we are given the initial temperature of the ball. So it is the hot object, and it is dropped into a sample of water. What is the initial temperature of that sample of water? Yes, it is 25.0. And the temperature of the water has warmed up, and the final temperature was recorded in the water as 37.3 degrees of Celsius. So what is the final temperature of the ball? Yes, even though it is not mentioned directly in the question, we need to assume, we should assume the ball should get the same final temperature as the water, and this will be dropped to 37.3 degrees of Celsius. So both objects have the same final temperature. Right. Okay. So the who is losing the energy? Yes, the ball is losing the energy. Therefore, it has a negative sign. The water is gaining the heat, so it bears a uh, positive sign. Let's determine the temperature change of water. So temperature change of water equals the final temperature minus the initial temperature. Final temperature of water is 37.3 minus 25 degrees of Celsius. And we get the value as 12.3 degrees of Celsius. Second, determine how much heat gained by water. We are given the heat capacity of water. So the Q of water equals the heat capacity of water multiplied by the temperature change of water. So the heat capacity is 1046 joules per degrees of Celsius multiplied by the temperature change for water, it is 12.3. We'll get 12.83 times 10 to the third joules as the heat gained by water. Third, determine how much heat ball bearing lost. How much heat lost by the ball. So Q of ball should be the value exactly equals to this one, but the ball lost the heat, therefore it now bears a negative sign. So it is negative 12.87 times 10 to the third joules. Determine the temperature change of ball. Okay, so the temperature change, the final temperature of the ball for the ball is 37.3 and minus 260.0. So it is a negative value. Look, yes, 222.7 degrees of Celsius. So now we'll calculate the heat capacity of the ball. So it is C equals Q divided by the temperature change, negative 12.87 times 10 to the negative times 10 to the third joules divided by negative 222.7 degrees of Celsius. So negative sign to negative sign will be cancelled out, okay? And we'll get the heat capacity of the ball as 57.8 joules per degrees of Celsius. So, when you look at an example like this, always keep that in mind. The final temperature of the both objects will be the same and one object will be gaining the heat, so that Q will be a positive value. The other object will lose in the heat, that Q will be a negative negative will bear a negative sign, but the q the numerical number of the q will be same, but only the sign will be opposite.